Statistics Land, and welcome to a Chapter 10 episode of Let's Play with Minitab and do some examples. If you're interested in finding this example file full of questions, you can find it just below this video, which you can find on Blackboard, obviously, on our course shell site. So I'm going to be doing 2 example problems using Minitab this time. So I already have my Minitab open, I've got my Word document here, and I'm just going to go through and do some Chapter 10 stuff. So I'm going to perform some hypothesis tests. Let's read the first problem. A survey claims that 7 out of 10 customers recommend Western drugs for pharmacy issues. To test this claim, a random sample of 100 customers is obtained from a list of reward customers. Of these 100 customers, 75 indicate they recommend using Western drugs for pharmacy needs. We would like to know, is this claim accurate? So, I want to come up with my null and my alternative hypotheses. So what I'm really curious about as I'm formulating these is I want to investigate what's going on here. So I read through this again, and what we want to look for when we're forming our alternative proportion is not equal to, it's always the null that's an equal to, p equals. I want to know, like, is there anything in here that indicates is it a one-tailed test or a two-tailed test? So when I'm looking for a one-tailed test, I want to look for, is it a less than, is it a greater than, there's something you want a more or less, or is, greater. It doesn't really mention any of that. They just want to know, is the claim true? Is it the same? Or is it different? And that's what cues us into the fact that this is actually a two-tailed. It's a not equal to. So I'm going to go up to Insert and then go down to Symbols and then choose Symbols again to get me a not equal to. You don't have to do this. You can just write not equals. So the last thing I want to do is I want to make sure that I'm doing this about a parameter, not a sample. So I look through here and find my sample. To test this claim, a random sample of 100 customers. Okay, so the 100 part is from a random sample. That's not about a parameter. What I want to do is test the claim, the one about the proportion that they say it's 7 out of 10. 7 out of 10 is 0.7, so that's what I'm going to be testing. I'm going to put 0.70 in here because I don't know why I feel like putting a 0 there, but I do, and my voice got too high, and I'm sorry. So there we go. That's what's going on. What I want to do next is I want to find the test statistic and the p-value and then state my conclusion. Okay, couple things in here. I'm going to be using Minitab, so I am not going to hand calculate any of this jazz. I'm going to rely on Minitab to do it for me and tell me what those values are going to be. So we're going to go over to Minitab. We have everything we knew at this point to do Minitab. Actually, really, once you have the null and alternative hypothesis set up, you can do Minitab to get the rest of these answers. So here we go. Okay, let's go through the steps to do a hypothesis test. We got our Minitab open. Let's go over to Stat, and then we choose Basic Statistics, and we go down to one proportion because this is a one proportion. Okay, so we notice that it automatically is defaulted to one sample in each column. My columns have nothing in them because I have summarized data. What I want to do is I want to do a hypothesis test. So I'm going to go ahead and, well, I mean, it's summarized data, so I need to change this to summarized data because I have a summary of events. Now it's going to ask me, well, what really happened? Well, I got to use my sample. So this is my evidentiary part. 75 out of my 100 people said this, and my number of events is my number of successes. That's 75. The number of times I tried this is my 100 people. And then I'm performing a hypothesis test. So I check perform hypothesis test and I put in the hypothesized proportion. So it's asking you, hey, what do you think the proportion actually is? Well, we said we think it's 0.7. That's our null hypothesis. 0.7. Oh, I know why I did 0.70. Because 75 out of 100 is 0.75. I keep thinking I need enough decimal places. That's craziness. You don't actually need that. Okay. The next thing up, I should check my options. You should always check your options with hypothesis testing. So let's click the button. We got to set this up right. I don't care so much about confidence level because I'm doing a hypothesis test. The next thing I should check is, well, the first thing you should check for a hypothesis test is their alternative to make sure it matches what you've got. This is a not equal to, it's a not equal to, we're good to go. The next thing you should do is make sure your method is on normal approximation because we are using the normal model to do our calculations. So we want this on normal approximation. If you click on this menu, it gives you lots of options. Usually it defaults to exact, but we're doing a normal approximation. Go ahead and hit OK, and then OK again, and you get your hypothesis test. There it is! Woohoo! It gives you your sample proportion, your confidence interval, bunch of junk you don't need. Here's what you do need. You do need your test statistic. We note that our z-value is actually 1.09. And then our p-value is 0.275. That's pretty big. Ooh, speaking of big, let me make this bigger so it's easier for y'all to read. Okay. I don't know why that was such an awkward laugh. It happens. Good times. Great math. All right. So the last thing I should do is I should state my conclusion. All right. So our conclusion is going to be, oh my, alpha is smaller than p, or p is greater than alpha. My p-value indicates that this is pretty likely. Okay. So what do we say? Well, we're going to fail to reject. What does that mean? Well, that means that the evidence suggests that the proportion of customers who use Western, what is this, medicinal pharmacies? Oh, Western drugs, sorry, is about 70%, or 7 out of 10, because that's how this was represented. And I'm going to say with a p-value, because my p-value is so big, of 0.275. There's our evidence. There's our suggestions. There's what we noticed. Done. That's it for that question. Let's go to the next one. Okay, question 2. A company that sells eco-friendly cleaning products is concerned that only 19.5% of people who use such products select their brand. A marketing director suggests that the company invests in a new advertising and labeling to strengthen its green image. The company decides that it also is going to test the market so that its effective marketing campaign can be evaluated. We're going to write a null and alternative hypothesis. I don't actually need Minitab to do this one. I just like this problem. Sorry. Okay, so what are we really interested in? There's my HO. There's my HA. I'm going to have to type these a little different because, as you can see, they look identical to everything I've done before. That's not helpful. All right, so what are we trying to figure out? Did this campaign improve sales? So are they getting more sales? Is this changing in such a way that my sales is actually increasing? So I'm really looking for, is P actually greater than that 19.5%? Did it get bigger? Which means my null is actually, do I think it stayed the same? Remember, your null is just an equality statement. It always is an equality statement, and your proposed value for the hypothesized proportion is always the same, so these are the same value always. So this is what a null and alternative would look like for this. Next, what I'm going to do is part B. Based on the data collected in the test market, the company constructed a 98% confidence interval for the proportion of all customers who might buy their brand. The resulting interval is from 16% to 28%. What conclusions should the company reach about the new marketing campaign? This looks like a waste of time to you, trust me. All right, so here's the thing. The hypothesized value that we think is true is in the interval, so it seems like that's a possibility. So they're going to fail to reject. Uh-oh. Darn. And here's where you're going to be careful. Since my confidence level is 98%, my alpha is actually 2%. So this is at the 2% level. Oh no, what's this all going to mean? Well, here's what we want to say. The data, oh, I'm not typing on here, that's weird. The data do not provide convincing evidence that the marketing campaign increased the proportion of customers who purchase their products. And here's a slight change. Since I don't know the p-value here at all, I'm going to use alpha at the 2% level of significance. So as you look at this, I worded this a little bit differently from what you might expect it. There are other ways to word this. I worded this in a way that's kind of lazy. I want to make sure I actually answer his question about the marketing effectiveness of this campaign they've been doing. So I'm addressing that in one sentence. If you'd have wrote this like, oh, failed to reject, it appears that the proportion of purchasers is about 19.5% at the 2% level. You didn't actually answer the question because the question was about, hey, was the test market effective? Did the campaign work? That's what the question was about. So you should be addressing that in your answer. Or you could just write an additional sentence like, oh, it appears that marketing campaign did nothing. Yeah, so there you go. There's a little fun example on connecting confidence intervals to hypothesis tests. Hope you enjoyed it.